Welcome to today's lesson. In this tutorial, we will solve multi-step equations that have no solutions and multi-step equations that have infinite solutions. So far in this unit, we have been solving equations that have only one solution. But does every equation have one solution? Let's look at this example. 3x minus 8 equals 3x minus 8. Well, that's the same thing equaling itself. It would make sense that if we plugged any number in for x, we would get a true sentence. This is an example of an equation that has infinite solutions. When your variable is on both sides of the equal sign, the equation may have no solution or infinitely many solutions. Let's first look at equations that have no solution. Solving an equation with no solution produces an equation that is not true. There will never be an intersection point like we have seen before. Let's see what this looks like in example 1. So here's our equation in example 1. I need to gather some like terms. I see some like terms on the left side. I'm going to take the negative 5x and the negative 1x and put those together. Negative 5x minus 1x is negative 6x. I still have my plus 7, my equal sign, and there's no like terms on the left side, so I'll just write that as negative 6x plus 2. Now we're to the point where I like to move my variable terms to the left side and my number terms to the right side. If I wanted to move this variable term because it's negative 6x, I put a positive 6x underneath it to cancel it away. I put a positive 6x on the other side of the equation. I draw my line and I cancel this out. But I see over here that negative 6x plus 6x would also cancel out, and I would have no variables here. I would still have a 7. I would still have my equal sign. I have no variables here, of course, and I still have a 2. So all my variables go away, and I'm left with 7 equals 2. Well, that doesn't make any sense because guess what? 7 doesn't equal 2. So we came down to a not true sentence. Remember, no solutions would yield a sentence that is not true, an equation that is not true. So when your variables go away and you're just left with numbers, if those two numbers are not the same, we have no solutions. And we write the words no solutions. If we were to verify this in Desmos and look at it graphically, if we graphed the left side of the equation as one of these lines and the right side of the equation as the other line, you would see that these two lines are exactly parallel. They will never touch each other. They will never have an intersection point. So that's another reason why we have no solutions. Let's look at an equation that has infinite solutions. When we have infinitely many solutions, solving an equation with infinite solutions produces an equation that is always true for all values of x. The two lines will always intersect. In fact, they will appear to be the same exact line. Let's look at what that looks like in example 2. I do have some parentheses on both sides, so it looks like I'm going to be doing distributive property first. Negative 2 times 3x is negative 6x. Negative 2 times 6 is negative 12. Here's my equal sign. Negative 3 times 2x is negative 6x. Negative 3 times 4 is negative 12. I have no like terms to gather, so I'm to the part where I move my variable terms to the left side and my number terms to the right side. So if I wanted to move this term, again, it's a negative 6x, so I have to put a positive 6x underneath it. I do that, of course, to the other side of the equation. I draw my line, and the whole point of that was to cancel this term away. But look, again, these terms would cancel away because that also makes 0. I'm left with a negative 12. I'm left with my equal sign, and I'm left with a negative 12. Well, this time, all of my variables went away, but this time, my numbers were exactly the same. Negative 12 does equal negative 12. So because this is a true equation, we have infinite solutions. We write the words infinite solutions. I could plug any number I want for x, and it would solve this equation. If we were to verify this in Desmos, we would graph the left side of the equation, and it would be this line. We would graph the right side of this equation, and it would be the same exact line. It covers itself up. It intersects everywhere. So therefore, there are infinite solutions. So there's two special cases. When your variables cancel away completely from both sides, if the numbers that are left are true, are equal to each other, we have infinite solutions. If the numbers that are left are not equal to each other, we have no solutions. I do want to show one last example, and it's example 3. This is back to when we have one solution. A solution of x equals 0 is still just the one solution that we've been finding before. But for some reason, when students get 0 as one of their answers, they tend to get nervous. Don't get nervous. 0 is another one of our numbers. Let's look at example 3. There are no like terms to gather, so I'm going to move my variable terms to the left and my number terms to the right. I see a positive x, so I'm going to put a negative x right underneath it. I'm going to put that on the other side of the equation. I'm going to draw my line, and of course this will cancel away because that's what I'm supposed to be doing. 5x minus 1x does not cancel away. It makes 4x. Minus 13, equal sign, and a negative 13 over here. So my variables did not cancel away like the other two examples. I need to move my number terms to the other side now, so I'm going to add 13. I'm going to add 13, draw my line, and that crosses away. I've got 4x, and that equals negative 13 plus 13 is 0. That's okay. 4 times x can still be equal to 0. All I need to do is divide by 4, and I'll have my answer. Divide by my coefficient, and I'll have x equals 0 divided by 4 is 0. This is a fine solution. It's just one solution. I can verify this if I wanted to. Over here, I can plug in a 0 right here for x. I can have 5x turn into 5 times 0 minus 13 equals, well, let's see, I'm not sure. And then x minus 13 would become 0 minus 13. Let's see what happens. 5 times 0, of course, is 0. 0 minus 13 is negative 13. Over here, 0 minus 13, again, is negative 13. This works, so therefore this is the solution, and only one solution this time. Thanks for watching these 3 examples, and we'll practice these special cases in class. See ya.